We saw that we can get more accurate updating of our y position by averaging our current and previous values of the y velocity. This gives us a time-centered or average velocity for updating the position, which is what we want. So let's see how to implement that in the spreadsheet itself. Now back to the spreadsheet. Here's our old data back in the spreadsheet. Now we want to add a new column for y with the centered formula using the average velocity. And let's add a third column for the exact formula, at least the textbook formula, that we would use. We're still beginning at 0 in both cases, ground level. Now remember, we were using this formula in which we are adding Vy, that's in C2, times the time step, which we're storing in $H $2. What we want to change is now using the average, or half, times C2 plus C1. So that's V, the current velocity, Vy, averaged with the previous velocity, Vy. Remember, we're in row 3 here, though, so we want to average 3 and 2. I notice I have a similar result to last time, although I have one more digit that I'm keeping. Let's apply this formula and come back up. So I see slight corrections here, pretty similar. Let's see what happens if we make our time step bigger. Let's take it back to a whole second. Now we see a bigger difference between the centered formula and the forward Euler or left end method that we were using, exclusively the old value of the velocity. And now let's use the textbook kinematic formula. Here we have our exact formula in column G, 1/2 gt squared. G is $k $2 here. A2 squared is our current value of time squared, plus the initial velocity, V0, is $I $2 in this cell right here, times sine of the angle stored in J3 times the time. So that's 1/2 AT squared plus V0 y times time. We apply that downward, and I notice we have exactly the same numbers at every time using our centered formula and the theoretical exact equation. Definitely an improvement, and even if I make my time step large now, a whole second, I can see that I get exactly the same numbers with both these formulas. So you might wonder, why would I use this technique of the centered time step? Well, this will allow us to add other things, other forces. For example, air resistance might be something you'd want to add to your code. And using this time-centered difference method would allow you to add that kind of less ideal effect.